Hello student, the question says an iron bar L1 equals to 0.1 meter A1 K1 and a brass bar L2 A2 K2 are soldered end to end as shown in figure 10.16. The free ends of the iron bar and brass bar are maintained at 373 and 273 Kelvin. Obtain the expressions and hence compute the temperature of the junction of the two bars, the equivalent thermal conductivity of the compound bar, and we need to find the heat current through the compound bar. First, let us try to find a general one, then we'll solve it. Suppose if you have a compound bar that is soldered in this way, and let us assume this has length L1 and the temperature here is T1. Let us take the temperature here is T2. We have to find something called junction temperature. So this is what we need to find. L1, let us say its thermal property is K1. Here this is L2 and its value is K2. And its area of cross section, generally in these cases the area of cross section both of them would be same. So the area of cross section is A here, the area of cross section is A here. Now how does the heat flow? Imagine this is high temperature, this is low temperature. So this would be T high and this would be T low. We know heat flows from higher temperature to lower temperature, so heat would slowly starts to flow in this direction. You can think an analogy of current flow here. Remember, at steady state, dq by dt is constant. Now, what is this dq by dt? Okay, this is simply a rate of heat flow. Rate of heat flow. This is similar to, even though right now for some students current electricity might be completed, for some it may not be. So this is similar to current flow. In current electricity, this is similar to current flow in circuits. So this is similar, not current flow. This is similar to current flow. That's why in the NCERT is given rate of heat current. This dq by dt is also given as rate of heat current. Even for current flow I also we write dq by dt, but here q refers to charge, here q refers to heat. I hope you understood this part. Then what is current equals to? You remember the famous equation V equals to IR. Similarly here also V equals to IR only. There V is potential difference between the two ends of the terminal. Here in this case the formula would be temperature difference between the two ends of the terminal. Like that, it could be temperature difference between these two, it could be temperature difference between these two, or you can take any, whatever you know. So delta T equals to I would be dq by dt, and the resistance would be L by K. This is the general formula. This, and remember, this would be the formula for resistance, this is the formula for current, this would be the temperature difference. We will use this formula in the NCERT. If you see, you will find dq by dt equals to Ka. They will take this term to this side, delta T by L. But I personally like delta T by L by K, because this reminds me of potential difference divided by resistance. Once you understood this logic, we will use some rules to solve the problem. Now imagine the heat is flowing from this end to this end and this end to this end. Okay, we can see when you use this formula, when you are using this formula, we can only use this formula for a given rod. For a given rod, dq by dt is this. If you want to use for a composite rod, you have to find something called K effective. We'll come to that later. But for now, for this is, let me call this first rod, let me call this second rod. We know these are attached in series. In series, whatever is the heat flowing in the first rod, it would be equal to the heat flowing in the second rod, or we can say heat current in the first one is equals to heat current in the second one. So heat current is simply temperature difference delta T in the first rod divided by resistance L1 by K1A, which is equals to delta T in the second rod divided by L2 by K2 into A. Now if I substitute the values, the temperature difference would be T high minus T junction divided by, I can cancel A here, it would be L1 by K1 equals to again T junction minus T low divided by L2 by K2. So quickly let us rearrange the terms. If I try to rearrange, we will substitute everything that is given in the question and we'll try to solve this problem. If you look at this question, he has given T high value is 373, T low value is 273. So 373 minus Tj, and K1 value in the question was 79, K2 value is 109. 79 divided by L1. L1 value was 0.1 equals to T junction minus 273 into denominator it will come to numerator. So this value is given as 109 divided by, this is also given as 0.1 only. Now we are simply need to solve this to find the value of junction temperature. Most of the time in these questions, length also could be equal for convenience. So if I cancel these two, I'll get 373 into 79 minus 79 into junction temperature equals to 109 into T junction minus 273 into 109. Bring this term to this side. So 373 into 79 plus 273 into 109 equals to 79 plus 109 into junction temperature. So if I use calculator to solve this, because NCERT expects you to use calculators, so it is okay to use calculators in NCERT. Many people try to solve this without calculators. Don't waste your time. You can spend that time on solving other competitive examination questions. So this would be 79 plus 109. So it would be 188 into T junction. So from this T junction would be 29467 plus 29757. So you'll get 59224 divided by 188. So 59224 divided by 188 would be 315.02 Kelvin. So the final answer on solving this, you got it as 315.02. So approximately I can write this as 315 Kelvin. But I hope you understood how we found the junction temperature. The current in this is equals to current in this. So current means potential difference divided by resistance, potential difference divided by resistance. Here temperature difference divided by resistance, temperature difference divided by resistance. And we got these values after substituting everything. And in the same question is asking us, this will be the temperature at the junction of the bars. The first one is done. In the second one, the equivalent thermal conductivity of a compound bar. So for a compound bar, he wants equivalent thermal conductivity. So let us get an expression for that also. Since it's a compound bar, this is in series. So the compound bar in series, In series, we can write R effective is equals to R1 plus R2. The resistance of the first one is equals to resistance of the second one. We can derive this, but right now not required. Resistance is L effective by K effective into A is equals to, most of the time they have same area. So it would be L1 by K1A plus L2 by K2 into A. Now L effective would be L1 plus L2 divided by K effective equals to L1 by K1 plus L2 by K2. If you see the given question, in given question, so this is the general formula. L1 is equals to L2, it is given as 0.1. Since L1 is equal to L2 in our given question, I can write here 2L divided by K effective equals to L by K1 plus L by K2. If I cancel L on all the sides, so 2 by K effective equals to 1 by K1 plus 1 by K2. So from this, 2 by K effective equals to K2 plus K1 divided by K1 K2. So finally, K effective value would be 2 K1 K2 by K1 plus K2. If I substitute those values, 2 into this is given as 79, this is 109 divided by 79 plus 109. So 2 into 79 into 109 divided by 79 plus 109. So it would be 188. So let us use calculators to solve further. 2 into 79 into 109 divided by 188. So 91.6, approximately 91.6 watt meter inverse Kelvin inverse. These are the units of K effective. In the third question, we need to find the heat current through the compound bar. We have to find the value of heat current. Heat current, which is simply dq by dt. If you want dq by dt, we can use delta T of first bar divided by L1 by K1A. We can use this one also, delta T of the second bar divided by L2 by K2A. Or else we can use delta T of the composite. If you assume we are replacing this with a single rod, by L effective by K effective into A. You can use any of these formulas. Composite means it is simply T high minus T low. L effective is L1 plus L2. K effective and A effective substituted. I'll use the first formula and solve the problem. So we get dq by dt is equals to delta T. We got delta T is 373 minus T junction, that is delta T, divided by L1. The value of L1 is 0.1 divided by K1 value into A1 value given in the question is 0.02 meter square. Now 373 minus junction temperature, we got it as 315 Kelvin. So 315, this denominator, when it goes to numerator, it will be in this way, divided by A 0.1. So if I do that, so we will get 373 minus 315, which would be 58 into 79 into 2 into 10 power minus 2 divided by 10 power minus 1. So 58 into 79 into 2 into 10 power minus 1. So 58 into 79 into 2. So you'll get 916.4. So the final value is 916.4. 9164 into 10 power minus 1. So it would be 916.4 watt. In the NCERT, there are like slight discrepancies because of the values that we have taken. So you can take this approximately as 916 watt. 58 into 79 into 2 divided by the rest of the values. Now we can use A effective and also solve this problem. If you select any one of them, you try to substitute any one of them and solve the problem. This is how we are supposed to solve the problem of the composite rod. Hope you understood how I have solved. Thank you.